I'll be in here for a second, get these guys started.
Okay.
And, but they'll make me go in and out and
Yep,
do a couple
no
things
problem.
I need to do. Okay, please tell me, are you done with independent? So who is done? Raise your hand. Emily and Trevor. Fletcher.
This
Fletcher,
one?
you have, what'd you say, one more? Okay, let me, you can sit there if you want to, but I'm gonna show them something.
Was it 10-5? Stefan.
Oh yes, it is Stephen.
Stephanie.
Steph.
Okay, finish, people who aren't finished, keep working for a few minutes, okay? Give me like 2 minutes. If you're finished, relax for 2 minutes, okay?
Morning, guys.
Morning.
Morning.
Fletcher. I'm live on YouTube.
things that I'm gonna be in the building, but I'm gonna be in and out of the classroom. So I wanna quickly maybe take 10 minutes at the most to go over how you do the next lesson so that people who are ready can start it. It's really easy. So if you're working on the independent, dependent events, just pause with that for right now. Go forward in your packet. I think it's, well, let me look at Fletcher's. Okay, so you're not, nope, I'm sorry, it's that. Okay, it says 10-4 counting principle. So it's back a couple pages from the independent. Tell me, yep, tell me if you can't find it. Okay, go forward, I think, for you. No, go forward, go back. 10-4 counting principle. Everybody find it? Find it, Zach? I think one.
Awesome.
Close.
Yeah.
Couple more back.
10-4.
Yep, so, all right, I'm gonna just go over this with you real quick. So, basically, hang on, it's not on the screen. There we go. Basically what we want you to be able to do is to use the counting principle to calculate the number of outcomes. So, you know how when I said, how many outcomes are there when you roll 2 dice? And at first you guys didn't know there were 36, right? Like it was, I think, a little surprising, like really? 36 ways those 2 dice can land? And I told you there was a shortcut to finding the number of ways the 2 dice can land, and that was that because there's 6 sides on the dice, so there's 6 sides on the first dice, 6 sides on the second dice, 6 times 6 is 36 ways the dice can land. So it was kind of interesting how that works. That's exactly what we're going to do with this. Here's an example. So all you're going to do is multiply the number of outcomes at each stage of the activity. So the stages, what I refer to as stages, would be like, if I'm going to flip a coin and roll a dice, that's 2 stages. If I'm going to roll a dice 4 times, that's 4 stages, 4 things I'm doing. So every time you do something in the activity, in the experiment, the number of outcomes at that stage in the activity, you multiply to all the other numbers of outcomes, and that'll give you your total outcomes. So here's an example of what you might see. Example, roll 1 dice, flip 1 coin. How many outcomes? How many outcomes are there when I roll 1 dice, flip 1 coin? Well, how many outcomes are on a dice?
6.
How many outcomes are on a coin?
2.
So 6 times 2 tells me there's 12 outcomes. That's really all there is to it. Here's another example. How many outcomes when tossing a coin 5 times? Well, how many outcomes on a coin? 2, right? So, but there's 5 stages in this activity because it's 5 flips, I guess, or tosses. So every stage there's 2 outcomes. So there's 2 and 2 and 2 and 2 and 2. So 2 times 2 times 2 times 2 with 5 times. So if I said it 5 times, it's 32 outcomes total possible. Okay, how could we have written that differently?
2 to the 5th.
2 to the 5th, yeah. So we could have just said 2 to the 5th power. It would be easier to enter your calculator as 2 to the 5th power. Other questions you might see, and I don't have them typed as examples, would be like, what if you were at a salad bar that had 3 dressings and 4 toppings? How many different salads could you make with like one of each of those? Well, 3 times 4 would be 12. We could make 12 different salads. Or if you had 5 pairs of jeans, 5 pairs of shoes, so 5 shoes, 5 jeans, and 8 shirts. How many outfits could you make? 5 times 5 times 8. would tell you 5 times 5 is 25, times 8 would be 200. Crazy, huh? But I mean, every time, even if you changed your shoes, that would be a new outfit. If you just changed your shirt but left the same pants and shoes, that's what I'm considering a new outfit. If you're making pizza, you know, and you have 2 types of sauces and 3 types of cheeses and 5 types of meats, you know, how many pizzas? You would just multiply each of those together. So it kind of makes sense if you think about it. Yesterday you were doing probability of independent and dependent events. So let's just say you were trying to find the probability of getting a 3 on a dice. So there's a 1 in 3 chance, or 1 in what chance of getting a 3 on a dice? 6, thanks, Fletcher. And what about a chance of getting heads on a coin?
2.
What is it?
2.
But what's the probability of?
1 out of 36.
Oh, yeah, 1.
1 out of what?
36.
But it's a coin.
2.
2. So this is like what you were doing yesterday. So I have a 1 in 6 chance of getting a 3, a 1 in 2 chance of getting heads. Together, that means I have a 1 in 12 chance of these 2 things happening. Probability of a 3, then heads on a coin. I have 1 in 12 chance of that happening. Where's that 12 coming from?
6 times
The
2.
12's coming from 6 times 2. So what you're doing today is really what you were doing yesterday, except you're only doing the bottom number. You know, you're not, there's a few questions they ask you to do this again, where they ask you to actually find the probability, and you have to do what you did yesterday. But there's a lot of questions that just say how many outcomes. Well, the total number of outcomes is always that bottom number of your probability. So that's really what you did with the bottom number yesterday. How many outcomes for the dice? How many for the coin? 6 times 2 gives me 12 outcomes. And that became our bottom number. So really, it relates to what you did yesterday. It's just a way to find the total number of outcomes in whatever you're doing. Buying pizzas, making outfits, flipping coins, whatever. So if you take a look at the problems, there's 2 pages there. There is the one that you're on 10-4, which has, what, about 10 questions on it? 8. And then you have a second page that goes with it that has 16 questions. Watch for questions that say probability of. If a question is worded like this, right? And then it has something in there, then you're finding the probability, not just the number of outcomes, but your answer will be a fraction. But if it's just saying number of outcomes, then it's not a fraction. But they do throw a few of those probability ofs in there. Okay? So I'm going to be kind of in and out, like I said. I'll get the answer key out. So if you know, you check an answer, you can see, oh, Mrs. Johnson, and see what the answer is. If you're doing it right, just do the best you can. If I come in to grab something, you can ask me a question if you want. But finish up the independent and dependent event page and try these number outcome using counting principle to find number of outcomes. Okay? I think you can do it. Do you have any questions for the moment? Okay, so just think carefully about how many choices at each stage. Oh, you just need to print something. doing?
Good.
Okay, thank you, yeah.
Oh, not a
I'll be
problem.
down on the computer lab.
Okay,
Ready. Or in the office.
I'll be here. Okay.
If it gets too loud, you can adjust it pretty easily.
Okay.
My room actually has working heat. You
Wow.
can turn it up and
How'd you
down.
get that? I'm gonna complain. Okay, guys, I'm gonna leave this right here, so if you need to check it. Okay, feel free.
Well, it's lucky, right? That's a lie.
On YouTube. Yes, my friend. Somebody sing. It was on the stream. Hey. There's 3 people watching.
Why are you on your phone?
Music.
Huh?
Music.
Well, you got music right here.
Okay.
Put the phone away. If I see it again, I'm gonna take it.